So, good afternoon, everybody. We will continue our course today on population society, entering a new chapter. And so I jump from chapter 1 to chapter 10, chapter 10 related to age and sex composition, just because it gives an overview of main topics in demography. And then we also go into the next chapters on the world population trends over time and also some main population trends in the US. And then we go back to chapter 2. Just to remind you, we had our first quiz that opened after our last class. Quiz 2 opens today at 2 p.m. as soon as the class finishes on Canvas. It's going to be open until 8 p.m. tomorrow. And then on 8 a.m. on Saturday, you're going to be able to see the correct answer if you made any mistakes. So it's going to be the same system throughout the whole semester. And the dates of the quizzes are in the syllabus. And some days we will not have quizzes because we have exams. And also the days after the exam, the first class after the exam, we don't have quizzes. And this quiz that ends today, again, can be any material that we have covered so far throughout the semester, not necessarily about this current chapter that I'm going to talk today. And so quizzes are cumulative, but not exams. This course, this lecture here on age and sex composition, I subdivide in these topics. First, an introduction, why we study age and sex in composition, in demography, in population studies. And then just to be more specific, talk about the concepts of age and sex. What is age and what is sex? How do we conceptualize them in demography? And then kind of explain previous studies, just to give a really quick overview of previous studies that found some general trends in population studies related to age and sex composition. So they look at several data from several different countries in several different time points, and they found these patterns, and all based on information related to age and sex composition. And then we're going to talk about population pyramids. Nowadays, population pyramids, we usually prefer to refer to them as the age-sex structure of a population, pretty much a graph, a bar graph, in which we have on one side men and the other side women, broken down by age groups. And you have seen population pyramids since high school. So it's pretty much that same graph that you saw before, and here gives to us a good overview of the demographic composition of your population. It simplifies it a lot. And going deeper into it, talk about age dependency, which is related to that example that I gave in the last class about the total dependency ratios when I showed that graph for China, India, and the US. We're going to talk about that. And also talk about this methodological issue in which some countries, the data that's collected about age, when we ask people about their ages, some countries, the information is not so reliable because some people have some age preferences. Instead of, for example, saying that they are 28 years old, they say 30. Instead of saying that they are 26, they say 25. So there's some measurement error there in the data collection. So there are some techniques that help us assert whether the data on age collected from the population is of good quality or not. And talk about sex structure in different countries, and also focus a little bit on sex ratio at birth. That's something that we're going to talk throughout the semester a lot. And then the process of people getting older. People are getting older because we are having improvements in mortality. When we are saying that we are having improvements in mortality, it's not that mortality is increasing. Mortality is declining. People live longer. and then we have a higher proportion of people in older ages. We experience population aging. So age and sex are the most important and relevant characteristics of populations, and they tell us about population structure, and they are usually known as the demographic characteristics. So when you are watching even like a news media discussion or political debate or in some other area, people ask you, oh, what's the demographics of that population? Usually people are asking, what's the percentage of children, the percentage of working age people, the percentage of older people, and also broken down by sex. What's the proportion of men and female in each one of these age groups? And of course, they can be more specific. They might want to know, demographics could be the average age of a population. Is any indicator related to the age and sex composition of a population? Age and sex are tied in with the three demographic components or processes: fertility, mortality, and migration. If fertility declines, we are going to have smaller proportion of children in that population. So that affects age structure. If in a specific population there is some preference and selective abortion is done when the woman, they are pregnant of a female baby, then that is going to affect also the sex composition. So we will have more boys being born than girls than expected. If mortality is much higher among men than female or the opposite, that will affect sex structure. Mortality, if it's really high in some developing countries among babies because they don't have enough resources, health services, that will diminish the amount of babies or children that you have in a population, and that affects age structure, smaller proportion of children. Migration. If a country receives a lot of migrants, they're usually concentrated in labor ages. Of course, we have older, younger people migrating, but usually immigrants, they are highly concentrated in labor ages, and receiving countries, we receive these immigrants around 20, 35 years of age, and that will affect the age structure of the receiving country, of having more people in labor ages, and the countries that are sending these immigrants, or the countries that have these immigrants getting out of them, we also have the age structure affected because they're going to have a lower proportion of people between 20 and 35 years of age in this example. So these components, fertility, mortality, and migration, they are highly associated with age and sex structure. Age and sex structure of a country influences fertility, mortality, and migration, and also the trends in fertility, mortality, and migration influence age and sex structure. And we talked already about that. There is a reverse causality there, right? In a country that has more children or more older people, fertility might be lower because you have less women in reproductive ages. Countries that have a lot of older people, and mortality, more people will tend to die proportionally in a specific time because the mortality rates are higher among older people. So age and sex structure influences fertility, mortality, and migration, and vice versa, right? So that's why it's important for us, if you're trying to understand the levels and pattern of fertility, mortality, and migration, to look at age and sex structure as well. And in terms of the concepts, age is an ascribed and changeable characteristic, usually in population censuses, age is defined in terms of age of a person at his or her birthday. The United Nations definition, estimated or calculated interval of time between the date of birth and the date of the census, the date of the interview, expressed in solar years. So, and in order to check the information about age, a lot of censuses and surveys, they could ask two different questions. They ask the age of the person and also date of birth. So just to check that information if the person did not report the age correctly. Sometimes you could have self-reporting being done wrong in some populations, and so that's why it's good to have two different sets of questions and to have a better idea of whether the age variable is well estimated. And related to that age heaping problem that I mentioned at the beginning, maybe someone is 23 years old and reported being 25 years old, but then that person, when the person reports date of birth, you see, oh, actually that person is 23. So that can give you a better measure based on date of birth instead of the direct age reporting of the person. Sex is an ascribed characteristic, and for most people it is unchangeable. And for most people, sex is fixed at birth, but there are some who change their sex throughout their life. And usually in censuses and in surveys, the variable sex, the question sex, is asked as someone self-classifying as being female or male. But there are more recent surveys that try to make it more flexible, add another category of non-binary and some other options there as well. But this is like more newer surveys, newer research projects have been doing that. But if you're looking at historical census and surveys, usually sex is collected as self-reporting being male or female, okay? And these words, sex and gender. Sex, for the most part, but not always, is an ascribed variable whose designation is based on biology. Gender, it is more related to how our society provides different opportunities to people based on their sex. And then that creates a lot of inequality by sex for that population. So I'm doing a gender study. So if I analyze, for example, that people with the same occupation, same age, same race, ethnicity, same region of residence, all these different characters experienced in the labor market. If women are receiving less money than men, let's say 30%, even controlling for all these characteristics that I said, there is gender inequality. There is income inequality by gender, by sex. In this case, I'm using the variable sex to analyze gender income inequality by sex for that population. So it is more often used when discussing non-biological differences between males and females. Our society still has a lot of gender inequality, and opportunities for women are not the same as for men. So they get fewer opportunities in terms of occupation, education, and so on. And that's more the case, that's really clear in the case of developing countries. So differences between males and females in migration, marriage, divorce, labor force participation, all the example that I just gave now, income, it's more related to gender studies. But demographers, we usually tend to use the term sex even when we are discussing non-biological differences. So biological differences are related to sex, but even we might hear a demographer talking about differences between men and women related to migration rates, to average income and everything, and they might use the word sex, even for non-biological topics, right? So it's just to explain that there are some nuances in the use of the word sex and gender. But whenever we are trying to understand why men and women have different characteristics, not ascribing by biology, but by how the society gives them opportunities, we are doing a gender study. And that can be done in demography as well with these major censuses and household surveys, okay? So I'm just gonna give you here some examples of how fertility, mortality, and migration, they vary by sex and age. So fertility varies by sex. And just to also be specific here, the difference between these two concepts, fertility and fecundity. Fertility is the actual production of children, how many children each one of the people that are re-interviewing they had, and they report how many children they had. Fecundity is the actually ability, the biological ability to produce children. If you know Spanish or any Latin language, these concepts are exactly the opposite. So fertilidad in Spanish is fecundity. Fecundidad is fertility. The same thing in Portuguese, the same thing in French, right? It's just, it can get a little confusing if you're reading about fertility in Latin language. But in our case here, whenever you're talking about rates based on how many children women had, we are talking about fertility, right? Whether people have the ability, the biological ability to have children, fecundity. And as we already talked, fertility based on empirical data, based on data collected for several countries in several years, more males are born than females. Usually the normal sex ratio at birth, what is sex ratio at birth? In a specific year, in a specific population, we count how many boys were born, and we count how many girls were born. Divide one by the other, multiply by 100. That's the sex ratio at birth. Usually the normal sex ratio at birth is around 105. What does it mean, the 105? For every 100 girls being born in that specific year, in that specific population, there were 105 boys. And that's related to that topic that I mentioned at the beginning of this course last week, that men, boys, baby boys, they have higher mortality throughout, actually, men have higher mortality than women throughout their whole lives. But when they're baby boys, they also have much higher risk of dying because they need many more resources, food, care, than baby girls. So in some way, nature adapted itself that we have more boys being born than girls, that you give that little bit of extra boys being born that they can die, and the society will have similar number of boys and girls. And that's related to that hypothesis that I mentioned, the fragile male hypothesis, in which biologists mention that boys need much more care. They are much more fragile than baby girls when they're first born. They need more resources, food, care from their family, more likely to die. So in some way, we have more boys being born. And there are some other explanations at the time that the conception is done, that we usually have higher chance of having a boy or a girl. So there's some more medical discussions about why we have more boys being born and why the male embryos are weaker than female embryos, and baby boys, when they're born, are weaker than baby girls. So here we are pretty much saying that fertility varies by sex, in the sense that more men are born than women. Another thing, the biological ability to reproduce, to have children, varies by sex, and also by age. Within each sex, we have specific ages in which we have higher chances of produce children. In demography, all these fertility rates that we're going to talk, the age-specific fertility rates, the total fertility rate, the net reproduction rate, the gender reproduction rate, and so on, all of those that we're going to talk specifically about then in the chapter about fertility, we ask women between 15 and 49 years of age how many children they have. And then we calculate all these fertility rates and reproduction rates. In this case here, wow, but I know people who have kids before the age of 15, or women who also have kids above the age of 49. But the rates, the fertility rates, are usually higher among these ages. So as a standard and historical way to compare different countries through time, demographers usually use the information of women between 15 and 49 to estimate fertility rates, exactly because of their biological ability of having children that's higher among these ages, okay? And for males, the ages between in which they have higher chances of having children is between 15 and 79. So you see all these older guys having children because they don't have to carry it. So it's much easier. And we have the ability to produce children varies much more by age among men, 15 to 79. This is one of the reasons of why fertility rates are calculated based on information from women, not from men, because that's really much wider range in which a man can have can produce children, can produce babies, that it's harder to collect this information from this wider population. It's one of the reasons. Another reason is not related to biology, is more related to actually our society. That usually women, they know exactly how many children they had, and they are the ones more taking care of the babies, because still we have a society that puts much more the care of the children on women, because related to gender inequality. So that's another reason that we don't collect as much information about fertility based on information of men. Men usually don't report that. That information is reported from women. So this is all to say that the actual production of children varies by sex. We produce more boys than girls. And the actually ability to produce children varies by age of men and women, right? And this is a really clear case, only looking at women. And these are the age-specific fertility rates. The age-specific fertility rates, as I mentioned before, the standard is to calculate the age-specific fertility rates between 15 and 49 years of age. And usually in these 5-year age groups, these are completed years. Women with between 15 and 19 years of age, 20, 24. So the 7 age groups with 5-year interval. And then you see that younger women, they have really lower chances of having children. It increases. So around the ages of 25 and 34, you have the highest rates, and then it declines again. You might see some specific studies actually looking for fertility of younger women, those between 10 and 14 years of age. So early teenage pregnancy or early teenage fertility, because in some countries those rates might be high, because this woman might have less access to education, might have less access to resources, and then they start having children early in their life. But usually whenever you're talking about the standard of age-specific fertility rates, it's within this interval of 15 to 49. How exactly we read this graph here? For example, between 2015 and 2019, 20 women in the US had one child, women between 15 and 19 years of age, out of 1,000 women in that specific age group. Out of 1,000 women in this age group, around 70 of them had babies per year in that specific year interval, specific time period. So far, I'm just talking about variation of fertility by age. But this graph also shows something interesting. It shows changes over time. It shows that based on the UN projections, we will see lower levels of fertility among women between 15 and 24 years of age, and higher fertility rates for women between 25 and 34. So we are talking here about rates. We get the number of kids that women had in that specific age group and divide by the number of women in that age group. So what's going on here? Why are those rates increasing? As our society starts to develop in a way that there is more opportunity, there are more opportunities for women to invest in their education, go to college, and then after they finish college, then they go to the labor market, and after they have a more established life, after all that, they will start to, they will get married and then have children. There is a postponement in fertility. So there are a lot of studies dealing with that, postponement in fertility. That women are investing in their education, they invest in their career, and that you see postponement in the age that they have children. Of course, that varies even within the US. Texas, for example, the age in which women have their first child, or the age in which women get married, on average, is lower than, for example, California or the state of New York, right? So there is variation there, but overall, if you're looking at a specific population, there is this process of postponement in fertility. Women now, more opportunities, they invest on their career, on their lives, on their training, and postponing forming a family and having children. And that generates a lot of different research questions for demographers. Because some people say, okay, women are postponing having children. Will that make the total fertility rate? What is the total fertility rate? The average number of children that women have throughout their lives based on information from a specific year. So that's that synthetic cohort information. Let's get these rates here in black. If we expose women to these rates here in black throughout their reproductive lives between 15 and 49 years of age, how many children on average they will have? So we pretty much just add this information here of these black dots in the graph and multiply by 5 because we have 5-year age groups, and we get total fertility rate. When women are postponing their fertility to later ages because of these societal changes, will they, by the end of their reproductive life, when they reach 49 years of age, have similar number of children as their mothers had or not? That's a research question that has been trying to be answered for several demographics in different countries. So they postpone it to later ages. So now they have fewer years of life to have children. Will they reach the same number of children on average as their mothers did in the previous generation? If they do, if they reach, let's say, around the same 2 children on average as their mothers had, this effect of postponing fertility is going to have a temporary effect only on the decline of fertility. This generation of women postpone to get a job. During this specific time that they're postponing, fertility declines. But as they reach 49, fertility will go back to the same level as their mothers. And the daughters of these daughters, they will start to have the same pattern of postponing fertility as their mother. So we have the grandmother, the mother, and the daughter. So the daughter and the mother will have similar now because the mother already postponed, let's say most that we could postpone. If the daughter is also postponed, but in a similar way as the mother, then we start to see less drops in fertility. So if that happens, we have a postponement in fertility, we see a drop in fertility in a specific time, but then afterwards it goes back, was a temporary effect related to tempo, related to time. Demographers say that this is related to a tempo effect in fertility. One of the most well-known fertility demographer in the country and the world, John Bongartz, did a lot of analysis and proposed a series of methodological studies to analyze if some drops or declines in fertility are related to period or tempo. Period means that this decline is going to be for a long time, or it's just temporary, related to a specific time, and then they will go back. What I'm saying here is like a simple graph like this raises a lot of research questions related to how our population is composed and is going to be composed in the future, and how the fertility levels and trends are going, right? So a simple graph of variation of fertility by age and also changes over time raises a lot of questions that demographers are trying to answer. And this postponement in fertility has been observed in other countries too, not just the US. A lot of developed countries have been seeing that, Eastern European countries, Western European countries. And the question is, are these women simply postponing or actually on average having less children? 1 children on average, 1.2, 1.3, and so on. 1 child on average, 1.2, 1.3 children on average, okay? What about mortality? Mortality varies by sex. We have already talked about that. Women have lower death rates than men at every age of life. This differential has been observed throughout the centuries and may be attributed to both behavioral and genetical causes. Males are more prone than females to engage in health or life risk-taking behaviors such as cigarette smoking. So that's a behavioral reason of why we see higher mortality of men than women. But also genetic causes, because like I mentioned, even baby boys are more likely to die than baby girls. Moreover, estrogen protects women from heart and blood vessels. Testosterone, in the opposite way, tends to promote higher blood pressure among men, suppress the effectiveness of the immune system, and increase thrombosis. So, related to biology, okay? So mortality varies by sex. And we usually have life expectancy of women higher than life expectancy of men. But more than that, mortality also varies by age. Death rates are high in the first year of life and then drop to very low levels. In modern populations, the death rates do not reach the level of the first year of life for another 50 to 60 years. So the risk of dying before reach 1 year of age is high. After we reach 1 year of age, the chance of dying declines a lot. And then it starts to increase as we get older. But this rate will reach the same level as when we were first born, just around 50 to 60 years after that. And moreover, cause-specific mortality is often age-related. And we're going to see that specifically in the chapter about mortality. But I think was on Tuesday, after I left class here and I was going back to my office in the academic building, I walked through the academic plaza and were several, was like information about suicide rates among college students. College students, younger, suicide rates are the second highest cause of death among college students, right? And that was even reported in the A&M website and the Twitter account and so on. So the cause of death varies by age, okay? And among younger people, accidents, suicide, this kind of causes, reasons of dying are higher than among younger and older people. Among the young adults is higher than among children and elderly people. This thing here that I just mentioned in the second point, how exactly do we see that in a graph format? Exactly here. We see this data from 2011, it's old data, but the idea is to see the pattern. We see the age-specific mortality rates for Japan, Guatemala, and Nigeria. Mortality rates higher in Nigeria comparing to Guatemala, and Japan has the lowest mortality rates here. Why it's called age-specific mortality rates? Because we get the number of people who die before reaching 1 year of age and divide by the total number of people with 1 year of age in that population in the middle of the period, as we talked in the previous class, how to estimate rates. Same thing, how many people died in 2011 in Japan between 1 and 4 years of age, and divide that by the number of people between 1 and 4 years of age that lived in Japan in the middle of 2011. So what we see is that infant mortality rate, so what is infant mortality rate? The first rate that is shown here in this graph, number of babies that die before reaching 1 year of age, divided by the total number of babies in that specific country in that specific year, in the middle of the year. So the level of infant mortality, even for a developed country, is high or is higher compared to other age groups. But as we get older, as we pass the risk of dying before reach age 1, the mortality rates declines a lot. And that's really clear to Guatemala here and also to Japan here. And then afterwards, mortality starts to increase. As we get older, our chance of dying starts to increase. But see that the increase in mortality here is going to reach the level of mortality from when we were babies several decades later. So only around 50, 55, you're going to reach the same levels here based on data from Japan in 2011. In Guatemala, only 65. In Nigeria, only around, if I would say 75. Of course, because the Nigerian infant mortality rate is so high that you're going to reach that really high levels only when people reach really, really older ages. I mean, I want to say really, really older age is bad, but reach older ages, age of 75. Okay? So this is to show that mortality rates vary by age. And of course, we have variation across countries and also through time. Japan, in previous decades, they had higher mortality and then it declines. And for these other countries, the same thing have happened. Okay. Migration also varies by sex and age. Especially in developing countries, sex is related to distance of migration. Long distance migration, the rates of migration are higher among men than women. So if you're talking about migration between countries or migration between states really far away, usually the rates of men are higher than the migration rates of women. Short distance migration tends to be higher among women than among men. And here we're talking again about rates, taking into account the size of the female and male population. With increases in gender equality, migration of females and males tend to be more similar. So the differentials in migration rates tend to be more similar in more developed countries, okay? So varies by sex. Immigration also varies by age. The largest numbers of migrants are found among young adults, right? Exactly, young adults are more likely to migrate compared to the rest of the population. And this is a typical curve of migration rates. Among children, really young children, migration is high, then tends to decline. And so declines around like 14 to 19 years of age. And then it increases again in labor ages, and declines, and then afterwards reach the low levels. So what are the possible explanations here? So children, so young children here, up to 10 years of age, around here, they tend to migrate with their parents. So the rates of these children here kind of mirror the rates of their parents, these ones here. These ones are people entering in, yep, Ethan.
Have a kid born in America that's a citizen, so that costs a lot.
All right, what's the?
I was wondering if this is an unusual graph because of that law. So there's unusually high amounts of younger kids and migration rates in the U.S. than it would be in other countries.
No, I mean, in this specific case, it's not the case because here we are talking actually about internal migration.
Oh, my God.
So it's inter-county migration. And actually, this one is the most typical curve. This one is what we would say that's a migration curve by age related to labor, related to the labor market. How is it related to the labor market? So children migrate with their parents, and these teenagers, they tend to stay with their parents and they don't migrate as much. Here they enter the education system, so they start to move to the college town or to the city where the university is located. And whenever they get a job, the chances of migrating increases even more because they are moving after they finish college to start a job somewhere else. As they get married and get settled, the chances of migrating starts to decline. And as we get older, we have more stable situation, the chances of migrating declines. And here we have a little bit of like when people retire, in some cases, you could see even an increase here of migration. That could be like around here, people retiring and getting and moving as well. And in this case of the US, these are people moving to institutions for the elderly population when they cannot take care of themselves anymore, right? So it's related to the labor market here, is related to family here, and is related to biological needs here, right? So again, a simple graph like this gives a lot of information. And Ethan, just one thing that you said, like, in this case, we see children migrating with their parents. I mean, of course, I don't know exactly if these children here are migrating exactly with their parents. It's an indication that this graph is given to us. But there are some curves that don't follow this specific pattern. That's why it's good to estimate these migration curves for other countries in other years. We see really flat rates, really low levels of migration among children. In this case, we might be seeing migration of parents somewhere else without their children. So these rates here are small, while these ones are high. And usually we see that when these migration rates are broken down by sex, by age and sex. So, for example, people migrating for economic reasons, trying to look for a job, and we focus on the migration rates of men, that can be both international migration or internal migration. These men will tend to move by themselves more than women. If they migrate by themselves, we're going to see a lower level of migration among children. But you might see a higher migration of women, of daughters, at this rate by only for women. So these are all interesting. But for example, the US, it's kind of like really well developed in all different areas. Of course, there are some areas in the US experience a lot of economic hardship. But for example, Brazil. If you know Brazil, São Paulo is the most well-developed state in Brazil, around Rio, and the northeast of Brazil is really less developed, and compared to São Paulo. A lot of people migrate from the northeast to São Paulo looking for jobs. That migration from the less developed region to the more developed region, the rates of children is really low. This rate here is really low. And these rates here is really steep because it's people really moving for jobs. The other way around, people moving from a more developed region, São Paulo, to the northeast, less developed region, then you see high rates of children, kind of like people moving back from São Paulo to the northeast, so they take their children back. And this curve here is not so steep. Instead of being so steep like that, it's going to be a little bit flatter, right? And analyzing these different flows of migration, the direction of areas that are more developed to areas that are less developed and vice versa, and looking at the different patterns, that's what demographers try to estimate and interpret. But these three graphs that I showed you here, fertility by age group of women, mortality by age group, migration by age group, they show the usual trend of the demographic components by age. Fertility is going to be usually like this, an inverse U curve, higher chances of having children around 25 and 34, and there is a postponement in fertility. Mortality, we have these high rates among younger babies, decline and then start to increase. And then migration has this more complicated pattern of high for children, declining, increasing labor ages, and declining again. But it varies, as the example that I just said. If you are moving from a less developed region to a more developed region, these rates of children will decline. If you are going back from the more developed region to the less, kind of like a return migration, you have children, steep, and this curve, instead of being so steep like this, will tend to be flatter. And it's interesting to analyze these changes over time, across societies, or even within the same country, analyze that between states, okay? And I mentioned, I will talk briefly here about some theories that try to understand how age and sex structure influence the demographic history of populations. Persons of the same age constitute a group or cohort who were born during the same period. Therefore, they have been exposed to similar historical facts and conditions. That's related to the discussion that we had about cohort. And these experiences also vary by sex, because usually men and women have different opportunities in societies. Income, home ownership, occupation, or group membership are likely to vary by age and sex as well, right? Societies that have a lot of gender inequality, we're going to see higher average earnings among men than women, higher proportion of men who own houses compared to women, higher proportion of men who are in more well-paid occupations than women, and so on. Okay? So age and sex structure of human population sets important limits with respect to how the societies sustain themselves. The demographic structure of age and sex contains the possibilities and sets the limits of organized group life, as Amos Hawley said. The degree to which a population's age and sex structure limits the kinds of sustenance activities is an important analytical issue, and is still not well explored or understood, or still we can learn a lot, right? With the idea that, what does it mean that having more people in labor ages might increase economic development in a specific country? But why some countries that have similar proportion of people in working ages don't develop as much as others? Is it because, for example, the Southeastern Asian countries, Singapore, for example, they experienced a lot of economic development in the 90s related, and what some demographers say, that's related to age composition. Fertility declined a lot, so we had fewer proportion of children in those countries, more people in labor ages. Those people in labor ages producing a lot, working, having jobs, well educated, and then that creates economic development to the society. Later in their lives, they have enough savings, and they will have a good life later on. The Latin American countries are passing through that same change in age structure right now, 2015 to 2030. Fertility declines a lot, and you have a higher proportion of people. Fertility declines a lot since the 70s. And then in more recent decades, you have a higher proportion of people in labor ages. But these countries are not experiencing as much economic development as, for example, these Southeast Asian countries. Why that? One of the hypotheses is exactly because the levels of education and training in productivity is really low in Latin American countries compared to the Southeast Asian countries. So we have to take advantage of having more people in labor ages in order to have better economic development. But if these people are not well trained in terms of having college degree and being able to perform high-level tasks and so on, because there is not a good education system and there are not enough opportunities for people. The proportion of people getting a college degree is still really low. In Brazil, around 13% of the population only, really low. So when these people enter the labor force, they still cannot get high-paying jobs and produce goods for the whole society. So all these different things, age, structure, sex structure, they are related to these other aspects in our society. In this example that I just gave you, it's related to education levels, right? So that's why it's important to keep studying it and comparing different countries. Cool? Some examples of theories, like Ainsley Cole, he developed, he saw different patterns of marriage rates by age, seeing that people, as they get older, of course, they start to get married. And then you have variations also by different countries, or even within countries by different states, as I mentioned earlier today. And why exactly that happened? Is that related to culture? That's related to religion. What is the reason behind why some states, some countries, some societies have higher women and men marry earlier than in other societies, right? Reason here, description of fertility patterns by age and the absence of voluntary fertility control. He pretty much tried to see how would be the fertility patterns if there was no contraception, right? Trying to see what would be the natural fertility. That we're going to talk more about it in the chapter about fertility. Natural fertility is the fertility that we would observe in a specific society if women and men are marrying early, they have good health conditions, active sex life, and no contraception. How many children they would have throughout their life? You could say, oh, but for example, in some developing countries, people marry early, they are having sexual activities, but their fertility is not so high as we would expect. But because the health opportunities for them, the health services are not as good. So in this case, here, what we're talking is more related to natural fertility. Natural fertility, condition that has to be there is good health, right? Good health services to the population. Andre Rogers, he retired recently from University of Colorado at Boulder. He pretty much developed a mathematical equation trying to understand migration patterns by age. Just going to go back to that graph of migration to the US. If we break down this migration here of, like, let's say, one state to the other, one single county to one single county, and analyze this information for 1 year, we're going to have really few people migrating exactly from that specific county to this other specific county. We're going to have a problem of small sample size. When you have that problem of small sample size, what's going to happen with this figure here? It will get a lot of spikes. It's going to have like a lot of like up and down from one age to the other, right? That up and down from one age to the other, it's not because this specific age group here has more or less than the other one. This is related more to data quality, to small sample size for that specific migration between that county to that other county in that specific year. In order to correct that variation, we have to pretty much implement a mathematical model using the data that we collect to smooth the curve. And I'm going to talk more about that in the class, the chapter about migration. So you're pretty much trying to smooth the curve. You smooth the curve, so it's more smoother like this one here. And then you can calculate this slope, negative, this slope here positive, and so on. You know what's the age group that has the highest migration rate. But in order to smooth the curve, to don't have so many spikes, as I was talking here before, you have to use a mathematical equation. And Andrew Rogers, he proposed that. And it's a really powerful methodological tool. The stable population theory. We're going to talk more about this when in the chapter about mortality, when you're talking about life tables, when we talk about how to estimate life expectancy at birth. When we estimate life expectancy at birth, we use this table called life table. And based on the life table, we can talk a little bit about stable populations or stationary populations, which is a specific kind of stable population. This is the most powerful and elegant formal mathematical theory in demography. It incorporates a population's age and structure and sex structure, particularly age. Basically, imagine this rates here of mortality in a table format. Imagine the age here in a column, and then you have the rate, the age-specific mortality rate for each one of these. Each one of these points will be a second column. Based on that information, on the age group and the mortality rate for each age group, we can calculate life expectancy at birth. So we have mortality varying by age. And if mortality, okay, varies by age, but let's say that mortality is not fluctuating so much anymore. Of course, during the pandemic, you have increased mortality among all the age groups and so on. But let's say that in more recent years, more developed societies, they reach so low levels of mortality that mortality is not declining so much anymore, has been stable. And let's say that fertility also declined so much in these last years and has been more stable. Based on this stable population theory, if mortality and fertility that declined so much in these last years and are kind of like stable throughout these last decades, and if they continue to be like that, we can project the population of that country by age and by sex for the next centuries in a really easy, straightforward way. The stable population theory does not take into account migration. When demographers are doing an analysis using a theoretical framework or methodological technique that they are not taking into account migration, they're taking into account just information about fertility and mortality, they are doing what they call a closed population analysis, saying that we are close to migration. But let's say that I say, oh, but the US, okay, mortality declined a lot, has been stable in these last years. I don't think it's going to change as much for the next years. Same thing for fertility. So I can try to project the population in the US using this stable population theory. But the stable population theory in the US is not going to be so powerful because of migration, because the stable population theory does not take into account immigration rates, and the US attracts a lot of immigrants. But it's a good start, it's a great start to try to project the population in the US with the stable population theory, with this assumption that fertility and mortality are more stable. And then after that, add information about migration, okay? And that's really cool. That's why demographers can, in a really efficient way, project the population for a specific country for the next 50, 100 years. Exactly what I just said now. The stable population theory considers a closed population, a population in which migration does not happen. So we are focusing on changes in fertility and mortality. if the age-specific fertility and mortality rates are constant and do not vary so much more in these next decades, if we expect that they will not vary as much more in these next decades, that society will develop a constant age distribution and grows at a constant rate. It doesn't matter how the distribution of the population was by age before. And we have information about population growth, which could be either positive or negative. Demographers sometimes indicate that the stable populations forget the past because we pretty much had a population that was composed by older people or younger people. It doesn't matter. If this mortality and fertility rates by age don't vary as much, then we will tend to have a population that doesn't change the age distribution as much and have a constant population growth. Age distribution of population of a stable population depends on the underlying age-specific mortality rates and the rate of growth. Age-specific mortality rates, as I mentioned just now, is the major information that we use in the life table to calculate life expectancy at birth. And in that case, the rate of growth, it's going to be much more related to the overall number of babies being born in a specific country. But if you say that fertility is not changing as much, the rate of growth is going to be influenced by what? If it's not mortality, if it's not fertility, it's going to be migration. If a country receives a lot of immigrants and have fewer immigrants compared to those that move in, we're going to have positive population growth rate. If more people get out than move in, they're going to have a negative population growth rate. Okay? The stationary population is in that case in which we do have mortality rates by age that kind of stable over time, fertility rates by age that are stable over time. What does it mean? Fertility rates that are stable over time. It means that we don't see these as much anymore. Data from 1 year, the black dots here, are similar to the next years. From this graph here, we see that the US is still not a stable population because the fertility rates by age are not constant over time. You are still seeing postponement in fertility. But if these rates start to be similar over time, and the same thing about mortality, if you look in different years for the same country, and then you have a stable population. And moreover, if that society has stable fertility rates by age, stable mortality rates by age, and the number of children being born in a specific year in that specific population equals the number of people dying in that specific population, that specific year, what happens? There is no population growth or no population decline. Let's say fertility rate, mortality rate by age stable over time. If the number of babies being born is higher than the number of people dying in that specific population, that specific year, what happens? Population increases. More people die, population decreases. The same, population doesn't grow, doesn't decline, it's the same over time. That third case of a stable population is called a stationary population. All of these three cases are stable population because fertility and mortality rates by age are constant. But when number of births and deaths is similar, no population growth, you have a stationary population. This analysis, again, I'm talking only about two components, fertility and mortality. I'm not analyzing migration. I'm limiting my analysis is not so complex. I'm limiting my analysis. I'm not taking into account migration. I'm doing the analysis only taking into account mortality and fertility. This analysis that doesn't take into account migration is called a closed population analysis. Doing this analysis as there were no migrants, immigrants or emigrants. Immigrants to that country or immigrants from that country. For the US, if we don't consider migration at all, after we do this analysis, it would not be a good result because there are a lot of immigrants. For countries that have net migration equals to zero, if they receive the same number of immigrants as they lose immigrants, net migration zero. So this kind of analysis is going to be much more reliable, right? And then the population pyramid is just us going back to high school, right? Population pyramid is a graphic, it's a graph that represents the age structure of the population in a specific year. It's also called the age-sex pyramid. But exactly due to changes in the shape of population distributions, this graph doesn't look as much anymore as a pyramid because people are getting older. You start to see more people in older ages, fertility declining, less people in younger ages. You start to see a different shape, start to be more rectangular. Pretty much, the population pyramid, there's like two bar graphs connected to each other. You have a bar graph by age, each one of the age groups here in these rows, for men and another for women, and put them together. They represent the male and female populations. Usually demographers use 1 or 5 year age categories, usually 5 year, because the 1 year can have that issue of age variation. A main characteristics of age transitions is a change from a very young population to an older population. You start to increase the population of older people and decline the population of younger people. In a graph format, this website is really interesting, populationpyramid.net. You can just select the country that you want and the year. It gives you the total population. And it gives you the age-sex structure for that specific area in percentage terms. So here on the left, we have men. On the right, we have women. And in each one of these bars, from 0 to 4, we have 6.8% of the population is between 0 to 4 years of age, men. 6.5 women. And this is a population in the world. I just selected the world to download this graph here. At the time, the overall population in the world was of around 2.5 billion people. Fertility is high, so we have a higher proportion of younger people compared to older people. As fertility starts to decline overall in the world and more people survive to older ages, so fertility declines and mortality declines, 2000, you start to see a little bit like a shrink of the first age groups and more people reach older ages, population now 6.1, and 2020, getting to much more rectangular shape. And of course, this pace in which we change the shape of the age-sex structure of population varies a lot by countries. And here in 2020, reaching a population of around 7.8 billion people. And the population projected to 2050 in the world, even taking into account countries that still have high levels of fertility and mortality, this graph much more rectangular than before. than 100 years before, and the population reaching around 9.8 billion people, according to these projections by 2050. Okay? And by 2100, even more. Fertility declining not only in developed countries, but also in developing countries. Mortality decline all over the world, more people reaching older ages, and the population reaching around 10.9 billion. Simple graph that you learn in high school, but if you break it down by year, by country, by state, by county, you get a lot of useful information. So 2 p.m., we finish today. Have a great weekend. I see you guys on Tuesday. The quiz is now open in Canvas, and I will continue on this topic here in the next class. Thank you.